Hi guys. So in this definition, we're going to go over how to create bent wood members with string tension members going in there to complete this surface. So for this definition, it's going to rebuild, so technically your surface may not look exactly like your Rhino model, but it's going to reconstruct it in a form that will make something adjacent or similar to it. So from here, just type in Grasshopper into your Rhino viewport, and we're going to open up the file called bent rods that I sent you. And the first thing you should see is the input surface here, and I'm just going to right click on it and set one surface, and I'm going to select my surface here, and as you can see, it should already set up these bent profiles here that should be resembling wood members, and it also sets up a string that hits down the middle of them and completes the bent wood member. So for now I'm going to hide the surface that I'm working with and just show you the faces that create in here. So I went with a triangular subdivision just so it works well with these bent wood members. And as you can see, there's two different members being bent here, one in the up direction and one in the lower direction. In the Grasshopper, we can adjust the size of our wood members right here. That's just for pure visualization, and I'll show you why next. And then also we can adjust how many different faces we have and how many bent wood members we can make. And again, this is already calculated for you. So if we wanted to add more in our U direction, basically you get kind of straight sections that correlate with our bent sections. We'll turn that down, and we can start to play with the V direction, which will add more and create more of a kind of a contouring moment with the facets going down the center. So as you can see, you get some really beautiful profiles happening with this, and it's relatively easy to do. So from here, if you want to start to fabricate this form here, and again, if you wanted to adjust your Rhino model accordingly or just update it slightly, say you wanted to move this point, this definition automatically updates everything in your Rhino model. So from here, we're able to just do real-time simulation of what our model could potentially look like. So I'm just going to go back to what we had at the beginning. And if we go over in our Grasshopper and we go to the very end, since there's three open plugs here, one that says ropes, sticks, and surfaces, let's just select them individually. So rope first, I'm going to hit spacebar, hit the bake button, and if I select my last created object, you can see here the ropes, or the string, is created for you. And there might be a few extra strings in between, but the main principle is that the ones that are going across are going to be the ones that are holding the sticks together. So I'm just going to group those really quickly. And I'm going to hide my surface for a moment. And now from here, let's get the pieces of wood or plastic or whatever your material you're going to use, let's get the geometry out. So I'm going to hit on sticks, hit my space bar, and hit the bake button. And again, we are left with the stick members baked into Rhino for us to analyze. And each one's individual. And next, let's get the skin that's going to go on this. So if we select surface, hit space bar again, and we close out a Grasshopper, basically you're left with how this model could potentially go together. Now it's not perfect, so who knows how well these sticks would actually hold, but for fabrication wise, if we take our facets right away, join them, sometimes you're able to unroll the surface, making sure that the explode is on no in one singular shoot. In this case, not so much, so what we'd have to do is just move this guy over, explode it, select one side, join it, select the other side, join it, and then hit our unroll button, explode no, And we have our template for the facets that are going to go in there. If we do that again, we have the other side of the template. From here, the string that's going to hold this structure together, you're going to have to measure in Rhino while working. But for lengths of these rods, and some of them might be doubled up, basically what you can do to get the lengths is to select one, explode it, select one of the surfaces here, and simply unroll it. And that's going to give us the length of that unbent rod. So that's the length you need to cut it at. So if we go to the next one, hit a surface, and unroll it again, you get the other one. So these are going to vary in lengths just to accommodate for this form. So again, this Rhino model is not physics heavy. So the biggest problem here is this is going to take a lot of testing to see if it works. But the end result can be very, very beautiful and have a very skeletal and ship-like aspect to it.